Bismillahirrahmanirrahim. Welcome to the first part of 19th lecture of statistics and probability theory. In previous lecture, we have started normal distribution. We have discussed some features of the normal distribution, in which we have discussed that it has a symmetric shape and it is bell shape, and its mean, median and mode are equal, and the area under the curve is 1. Later on, we have discussed the probability density function of the normal distribution and z-scores, in which we have transformed the random variable x into the variable z, and the resulting density function will be standard normal distribution function. We will continue with the topic normal distribution. As normal is the continuous distribution, so the graph of the distribution is the bell-shaped, as we have discussed. So normal curve is symmetrical, two halves identical. It is identical, that is, this is the center of the curve. So this part is identical to this part, that is 50% area is here and 50% area is here. Total area under the curve is 1. Mean, median and mode are equal. These are the tails of this curve, and theoretically curve extends to minus infinity from the left side, and curve extends to positive infinity from right side. So this is the shape of the normal distribution, and this is the way we represent the normal distribution. So area under the curve, how we will find the probability under this normal curve? As you know that normal distribution is a continuous distribution, so obviously we will find the area between 2 points, as we have discussed in the lecture of continuous distribution function. So let's suppose x1 and x2 are any 2 points on the normal distribution curve, as this is the normal distribution curve, and this axis is representing the values of the random variable x, and this x1 and x2 are any two values in the range of the random variable x, where x is between minus infinity to infinity. Now, so let's suppose the mean of the distribution is 0. This one is the mean. Now, probability x is less than x1. So you have to find this probability x less than x1. It means that you have to integrate the probability density function of the normal distribution of the normal probability density function of the normal till the point x1, where x1 is some value in the range of the random variable x. So the probability density function is, this one is p of x is equal to 1 over sigma under root 2 pi e raised to power minus x minus mu whole square divided by 2 sigma square, as we have discussed in previous lecture, and the limit is of the random variable is minus infinity to infinity. So what you have to find? You have to find the probability x less than x. As it is already discussed, just for the sake of reminder, if we write probability x less than x or less than equal to x, both will be equal in case of continuous distribution function, continuous probability distribution function. So what we will gonna do, we will integrate this function, this density function, which is 1 over sigma under root 2 pi e raised to power minus x minus mu whole square over 2 sigma square dx, and the upper limit is x1 and it's starting from minus infinity. So this is the way to find out the probability x less than equal to x1. And if you want to find probability x greater than x2, so what you will gonna do, probability x greater than, or you write it in this way, greater than or equal to, both will be the same in case of continuous probability distribution, but this will not the case. This will not be the condition in the case of discrete. In discrete, less than and less than equal to are two different things. So probability x greater than equal to x2 will be, we will integrate the probability density function sigma under root 2 pi e raised to power minus x minus mu whole square over 2 sigma square dx, and as it is greater than x2, so it will start from x2 and will end at infinity. So this one is the probability x less than x1, this one is the probability greater than x2, and this one is probability x1 less than x and less than x2. You can write this in this way also, both have the same meaning. So this is the scenario for the normal curve. You can highlight the area in this way, and you can find out the probabilities in this way. But what's the problem here? The main problem here is that you have to use the rules of integration here to find out this probability, and plus you will have the approximate results in this case if you able to solve all this scenario by hand or manually. So this will be a difficult task for you. So to make it easy, what you will do, you will transform this variable x into new variable z, which we have already done in previous lecture. Now z is the new random variable, and what's happening here, z is following standard normal distribution. It's following standard normal distribution with mean 0 and variance or standard deviation. You can say variance or standard deviation. In both cases it will be 1. So this is the way. Now we have this new random variable z, and we have this distribution, standard normal distribution. Now this if we concentrate on this table, this is the values for the random variable z here, and this one is all the body of the table is representing the probabilities calculated on the particular value of the random variable z. In what way? So entries in the table give the area under the curve between the mean and z standard deviations above the mean. For example, for z is equal to 1.25, the area under the curve between mean 0 and z is 0.394. So if z is 1.25, let's suppose this is 1.25, this is 1 and this is 2, so here somewhere it will be 1.25. So the characteristic of this table is that these probabilities are calculated from some particular point z to the mean 0. So as this is standard normal distribution, so mean of the distribution is 0, as it is obvious. So each probability is calculated from 0 to some specific point z. Now here they have taken the value z is equal to 1.25. So where is this is the random variable z? So you will go to the 1.25. This is 0.0. Here we will have 1.2. So this is 1.2, but you have to find the probability at between mean and the point 1.25. So this is 1.2. You will search for the 0.005 here in the first row. This is the random variable z, and all these values are representing this random variable. This one is 1.2 and this one is 5. So 1.25. 1.2, and here you will look for the 5. If you search in this column, it will be 1.20. If you will search in this column, it will be 1.21. And if you search in this column, this one, so it will be 1.25. So we will start from here, and from here we have to go to the column containing the 0.005, and this here. So this is 1.25. So what's happening here? This area between 0 and z is 0.3944. So if we write it in this manner, it will be, let me rub this. We use the eraser here and this like, okay. Now we have some space to write. So this will be probability, and your random variable is set here. Keep in mind 0 less than z and less than or less than equal to 1.25. As you can see, this probability is from 0 to this. Let's suppose this is basically the 1.25 value, and this axis is for the random variable z. So that's why I'm taking z as the random variable. So the probability between 0 and 1.25 as z is equal to 1.25 here. It is written here. So it will be 0.3944. This is the probability. 0.3944. So this is the easier way to find out the probability between 2 points for the standard normal distribution, and it is benefiting you in this way that it will give you the freedom from calculating this ambiguous thing, which is obviously difficult. And you will, if you can find out in any way, it will give you approximate result. So this is the easier way to find out the probability between 2 points. And let's suppose if we want to find out the probability, need some space here. If you want to find out the probability between the mean 0 and minus 1.25, so what will you do then? 0 and minus 1.25, as z is the random variable and its limit is from minus infinity to infinity, so that can take the value minus 1.25. So what will we do? In this case, let me rub this. Now, in this case, this will be probability. So if you concentrate on the graph, minus 1.25 will be somewhere here. Minus 1.25. So you want to find out this area. So how you will find out this? This will be probability minus 1.25 less than z less than 0, as z is the random variable and this one is from minus infinity to plus infinity. So this one is the starting point, so this will be minus 1.5 to 0, and what will be the probability or what will be the area between these 2 points? So if you concentrate on the table, the random variable z just have the positive values: 0.0, 0.1, 2.4, 3.4. So how can you find out the value z is equal to minus 1.25 from this table? This is the point to ponder, from where we will have the area between these 2 points, as he does not have the value of the random variable minus 1.25. So if you go back to the 4th slide, what it has written here: normal curve is symmetric, 2 halves are identical. This part is exactly identical with this part, and if you are in standard normal curve, let's suppose this one is standard normal curve. So if this is standard normal curve, so its mean should be 0 and variance should be 1. So if its mean is 0 and variance is 1, and this one is identical, if this is the point 1 and this is minus 1, we have moved one step further here and one step backward here, but both have the same area. If you recall, normal curve is symmetric and 50% data is here and 50% data is here. So this one and this one will have the same area. So you are looking for minus 1.25. If I use the eraser here, if you are looking for minus 1.25 and you have the table value 1.25, here somewhere here it should be minus 1.25 and somewhere here it should be minus 1.25. So as you know from this from here that area between 0 and 1.25 is 0.3944. This area is 0.3944. So as they are, this side is identical to this side. This one is 1.25. This one is minus 1.25. So area between minus 1.25 and 0, it should also be 0.3944 because both have same magnitude, but they are in opposite direction. This one is in this direction and this one is in this direction. This is positive and this is negative, but the area between this from this point to 0 or from 0 to 1.25 will be 0.3944. So we will have the probability minus 1.25 less than z less than 0 again equal to 0.3944. Please note down one thing. Many students do this mistake that they write the sign negative here. This is wrong because this is basically the probability, or you can say this is the area. Both area and probability can't be negative because area is the space or the space between 2 points and it can't be negative, and probability is obviously between 0 and 1. It also cannot be negative. So don't do this mistake. Don't write negative here. This minus 1.25 and 1.25 have the same area from the mean. It doesn't mean that this value will also contain the negative sign. Both will be positive 0.3944 and this will also 0.3944. So this is the way to look at the table and how to find the probability between the mean, this is the mean, to some specific point either in this direction or either in opposite